2.1 Greatest Common Factor GCF and Factoring by Grouping. So the last video I showed you how to find a greatest common factor. So here we're gonna actually learn how to factoring out the greatest common factor of a polynomial. So the very first step is find the greatest common factor of the terms in the polynomial, then divide this monomial or monominal factor into each term of polynomial, resulting in another polynomial factor. So like I mentioned back in module 12.7, factoring is division. So basically the way what we're doing here is dividing polynomial. Find a greatest common factor, then divide into the polynomial. So this is division. This is basically opposite of multiplying. Okay, basically it's going to be opposite of distributing and opposite of FOIL methods. Okay, so all the technique that we learn about multiplication of polynomial, here we actually going to do it in reverse, which is called factoring. So factor the given polynomial by finding the greatest common factor, all right, and rewrite the expression. So this polynomial, I got two terms, okay? Number first, then we do variable. Between 6 and 33, what's my greatest common factor? That got to be 3, right? Because 3 can go into both 6 and 33, all right? For the variable, x repeated between both terms, choose the smallest exponent, which is x. Y repeated between both terms, choose the smallest exponent, y. So that means 3xy got to be my greatest common factor. So once we write the greatest common factor, then we say times parenthesis. All right, now we divide. 3 go into 6 2 times. X go into x. So I don't say it quite like that. My greatest common factor x go into my first term x got to be 1 time. The way I say it is, since I'm taking 1x to the outside, then my first term in the inside should not have any x's. Y go into y squared, or we can say take 1y away from 2 of them. Okay, then that means I should have 1 more y left for my quotient 2. Because basically what I'm doing is y go into y squared, which is quotient rule, where we subtract the exponent. So rather than say it like that, I would simply just say take 1y to the outside, then there's only 1y left for my first term. Alright, let's do the second term. 3 going to positive 33 is positive 11 times. Take 1x to the outside, then 1 more x left for my 11. Take the only y to the outside, or y going to y, exactly 1 time, or no y left for my 11x. So that's it. My answer, 3xy times 2y plus 11. This is called factoring out the greatest common factor. So this looked just like, right now my answer looked like a multiplication of polynomial where I can do distribution. Okay, so this is basically, so factoring is basically opposite what we learned before back in module 12. All right, it is very important that we understand after we finish factoring, all the answer is only one term. All the answer has one term because this becomes multiplication between multiple factors. All right, now a lot of times students ask, how do we check our answer? Let me write it down here, okay? Let me type it out. All right, how do we check the answer? How do I know whether I factor right or not? All right, most of the time teacher teach to check the answers, we will just multiply them back out. Multiply again, or the answer just multiply back out, or do distribution. That is actually not 100% accurate. Okay, rather than multiply, the way you check them, okay, the way you check whether you factor completely or not is basically check what's inside the parenthesis. If we did not factor out the greatest common factor, if we did not take out all the greatest common factor, then what's inside the parenthesis, however many terms I got inside parenthesis, there should be another common factor, okay, between all the terms. So if you look at the 2y and positive 11x, there's actually no more greatest common factor between those two terms. So that means I factor out all the greatest common factor, okay, to the outside the parenthesis already. All right. Why multiplying again, or multiplying things back up does not always work? Because if we did not factor out the greatest common factor, if we miss anything out here, then multiplying back out will still end up with the original polynomial anyway. So if I will purposely, let me write this, okay? If I will purposely say 3x was my greatest common factor inside of 3xy, 3 going to 6 2 times, take the only x to the outside, so there's no more x left for my 2, but I still got y squared left for my first term. 3 going to positive 33 is positive 11. Take 1x from 2, 1x left. All right, did not factor out any y, so 1y is left. So if I will multiply this back out, 3x times 2y squared is still going to be 6xy squared. 3x times positive 11xy is still going to be positive 33xy. But this is actually the wrong answer, because between the two terms in the parenthesis, I still have a y I could have factored out. Okay, so instead of trying to multiply them back out to check for your answer, the best way to check them is check what's inside the parenthesis. See if there's any more greatest common factor left over. If not, then that would be your answer. All right, got to know your greatest common factor. Got to know your greatest common factor. All right, between these three terms, 2, 22, 10, I can factor out a 2. All right, x repeated between all three terms. Choose the smallest exponent, which is 2. All right, so y did not repeat between all three terms, so I cannot factor out any y. So let's see what's left. 2 going to 2 one time. Take both x to the outside, so no x left. So that means my first term in the parentheses should be just y to the third, right? Okay, remember now we're dividing. 2 going to positive 22, positive 11 times. Take both x to the outside, no x left for my positive 11. 2 going to positive 10 is positive 5 times. Take 1x to the outside. Excuse me, take 2x to the outside. That means my 5 should only left with one of those x. There you go. That's my answer. Factoring out the greatest common factors. All right, let's check out this one. All right, I got 3 terms here. First thing when it comes to factoring, the first thing we always check is checking for greatest common factor. Between 35, 7, 35, I know I can factor out a 7. All right, x repeated between all three terms. Okay, smallest exponent is x to the third. Y repeated between all three terms. The smallest exponent is 1, so I can only factor out y to the first. So let's see what's left for my 3 terms. 7 going to 35 5 times. Take all 3x to the outside, no x left for my 5. Take 1y to the outside from 3, y squared is left. 7 going to 7 is positive 1 time. Take all 3x to the outside, no x left for my middle term. Take 1y away from 4, y to the third is left. All right, so that's what's left over for my second term. 7 going to positive 35 is positive 5 times. Take all 3x to the outside, no x left. All right. Take this only y to the outside, no y left for my 5. So that must be my answer. Now, this problem I can probably write. Well, I'll probably leave it like it is. I could have swapped the y to the third and 5y squared back and forth, but it's not necessary for this particular problem, because when I multiply it out, I don't want it to be different order than the way how it comes. If I have a trinomial, though, if I have a true trinomial, I will probably rearrange them. But this is not a true trinomial, so we'll just leave it like it is. All right, between -3, -6, and -9. Okay, since all three terms are negative, I can factor out a negative. Between 3, 6, 9, I can factor out a 3. All right, x repeated between all three terms. I'm going to factor out an x. Y did not repeat between all three terms, so I'm not going to factor out any y. So let's see what's left. -3 going to -3 is positive one time. Take the only x to the outside, then no x left for my first term. So my first term was just left with y squared. -3 going to -6 is positive 2 times. Take one x away from 3 of them, x squared is left. -3 going to -9 is positive 3 times. All right, take the only x to the outside, so no x left for my last term, positive 3. So this must be my answer right here. Okay, so factoring out the greatest common factor of a polynomial is probably one of the most important topic that we encounter when it comes to factoring polynomial. So so this is something that we all have to work on over time. Okay, if we missed the greatest common factor, then what we have inside the parenthesis is actually going to be inaccurate. Okay, so got to factor completely. That's what that means. It's factoring completely. That means no more greatest common factor left inside the parenthesis. All right, that will conclude this lecture video on how to factor out the greatest common factor of a polynomial. Thank you for watching.